Hey everybody, this is Mr. Murray. Yesterday we did some work on density. So hopefully you did the work and submitted that short quiz that I gave you. A couple things you should know now: how to manipulate an equation, solve for what's unknown, plug your values in, whether you're solving for density, mass, or volume. So density equation is density is mass over volume. You also should know that if I have something that's more dense, suppose I drop that in water, if it's more dense than water, it's going to sink. If it's less dense than water, it's going to float. So substances will layer based on their densities. So today we're going to do a lab, and we're going to get to determine the density of 3 different samples. Now, where I posted this information for this video, I also put this sheet up there. So hopefully you were able to print this. This is our lab data sheet. If not, write this data down, because your submission is going to be your submission is just going to be the density of these 3 substances I'm going to give you. Okay, so let's talk about substance number 1. So sample 1, this is like a regular shaped object. Easy for me to determine its mass. First of all, I'll determine its mass, and I'm getting a mass of 65.82 grams. Okay? Its volume now is simply length times width times height. It's a perfect cube, so each measurement is the same, and I'm getting 2.1 centimeters. So it's 2.1 centimeters by 2.1 centimeters times 2.1 centimeters in height. All 3 are the same, so that gives you your mass, that gives you your volume, and from that you can just simply plug in your mass and volume to get your density. Sample number 2 is a cylinder. Now this cylinder, I mean, I could go out and do some measurements and determine its, using the volume of a cylinder formula and figure out its volume, but I'm not going to do that. I'm going to show you another technique. So first of all, let me get the mass. And my mass is 57.71 grams. 57.71 grams. Now to get its volume, I'm going to do that by displacement of water. So simply what I'm going to do is I'll get a volume of this water that's already in here. It doesn't matter how much water you start with, as long as it's not going to overflow the top or overflow the level where this is a graduated cylinder, okay? So it doesn't overflow the measurements, the ability for this cylinder to measure, okay? So I'm going to start with, and when you read this, you read to the bottom of the meniscus. So I'm starting with 39.5 grams. So that's my initial volume. That goes on your data page. 39.5 I said grams, milliliters. 39.5 milliliters. My final volume is going to be how much water gets displaced by this cylinder. Now, this is metal. This is Pyrex, which is a form of glass. So I'm not going to sit there and drop this right in, and I'll end up shattering my vessel, my graduated cylinder. So what you want to do is turn it to the side so you can slide it in. This is the lab technique you're going to use, so you don't break the piece of glassware. Okay? I'm going to let that settle down a second. And I'll read to the bottom of the meniscus again, and I get 46.3 milliliters. 46.3 milliliters. And since I'm not with you here, I'm going to actually do this calculation. So by difference, you're going to get the volume. So it went to 46.3. You start it with 39.5. So by difference, the volume of this is 6.8 milliliters. You have a mass, you have a volume. Now you can go ahead and figure out that, you can go figure out the density of sample 2. Sample 3, okay, let me get rid of this. Sample 3 is, an irregular sample, okay? I mean, and this could be anything. This could be, this object this could be an apple, this could be, you know, anything you're trying to get the volume of. In this case, I can't put this in this cylinder, so I need some other way of getting the volume. And what I'm going to use is something that's called an overflow container. I'm still doing the same thing. I'm still kind of seeing how much water it'll displace so I can get its volume. All right, so I actually know the weight of this. The mass is written right on the top of it. And my mass is 295 grams. Okay, so what I'm going to do, I've got this thing filled with water. I'm going to put this object in it, and I'm going to allow the water to overflow and from this here, and the water will flow into this graduated cylinder. So let me just I overdid it. Okay, just hold it. Just keep taking. Okay. I went a little too fast there. Okay, second trial, here we go. Just moved the wood a little too fast. So now I won't overflow it. Ideally, I probably should use a paper clip or something not hooked on so I'm not pulling water out with my hand, because my hand got water on it. That does mess with the volume, but I'm left with slave to what I have available to me, okay? So from that volume, it displaced this much water. This total reading has to be the volume of that irregular shaped object. And I'm gonna do the same thing. It's good to set it down, read the bottom of that meniscus, which I'm saying is 69.5 milliliters. 69.5 milliliters. So, you've got the masses and volumes of all these samples. You're simply going to take your density as mass over volume, and you're going to submit the densities of these three objects. As always, guys, if you get confused by any of this, rewind and rewatch the video until everything makes sense. Okay, this is Mr. Murray signing out. Guys, have a good day.